Hey Parth,
Hey,
you
hi
just
Vivek,
added
what's up?
all good, and you just added me and removed me.
Oh,
Perfect. Yeah.
okay.
How is this evening going, Parth?
Evening going. Reactor is completely full with another in-person event that's going on with the startup thing,
Very
and
good.
I even see this fun today. I see a lot of people at backstage.
Yes, it's going to be fun today. And by the way, I'm Vivek, senior cloud advocate, and I've been running Azure Happy Hours for 3 years now. It's fun to be back. And before we start and bring in guests today, let us go through the code of conduct.
Yep. Before we begin, please take a moment to read our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding of differences, being kind, and consider it in a way you all engage. We do encourage you to participate. Yes, to ask questions. Please drop all your questions in the comment section and our speakers will take the questions from there. Over to Vivek to begin the session.
Thank you, Parth. I'm going to bring in guests today. I don't want to waste any more time because it's going to be a full packed 1 hour
Cool.
session. And I have amazing guests. I have Ramya and
Hey, hi.
Drew. And I have to apologize for Drew. He's joining us from Redmond, and I don't know what time is it. It's 5 a.m.
I it's 3:30 a.m. right now.
Three
But
thirty a.m.
hey, it's all
Okay.
good. This is
God.
exciting to talk about, so I'm glad to be here.
Yep, and I'm glad that you're here because our audience, India audience, get to hear from you, who is basically building that particular product, and Ramya is here as well, who is building the functions as well. So both of you are senior program managers. Drew manages the Azure SQL and basically SQL, and Ramya is here from the functions perspective. So she's a senior program manager from the functions team. So welcome to the Azure Happy Hour show. And yeah, and audience, let us know where you're joining us from. In the chat so that we know where our audiences are, and we can get started as well. So, Ramya, to get
Hey,
started with this today's event, thank you, Parth, for the
over to you guys.
introduction.
Yep.
Thank you. So, Ramya, um, let us get started with a very basic question, right? What is serverless? Why do we need serverless? I'm sure there will be a few folks in the audience who have this question, and let's get started from there. I know we're going to go very in depth in terms of going and playing around with triggers and other things, but let's get started with a very basic question. What is functions, and why is serverless, and why this revolution? I'm going to
Yeah,
bring your slides as well.
yeah, sure. Thanks, Vivek. Thanks for having me in the show. Really excited to be part of Azure Happy Hours, and thank you for introducing us as well. I think you know that's actually the question that you just asked is actually my the opening thing of this slide. So let me first get so just to put some things in context here, so serverless. I'll first talk about the serverless piece, and probably the functions as a service part, and then probably talk about what we are gonna see in today's session, right? So serverless is about being able to build applications, right, without managing infrastructure, and this will essentially reduce the time and the resources that customers spend on infrastructure related requirements, and these serverless offerings are fully managed end to end, and this will ultimately boost the developer productivity. It helps with optimizing their resources. They could also focus on their code and business logic instead of infra provisioning and management, right? And Does that help, Vivek, from a serverless standpoint? Do you have any follow-up
Yes,
questions?
yes, definitely, definitely. So, I whenever I talk about serverless, I usually tell my story. I mean, obviously, I've been in industry for 17 years, and 17 years back, the way we used to do the development, we used to sit there and go into the server rooms, obviously wearing those jackets and all because it's cold in server rooms, and installing applications and all those things on the server, and then accessing it. But those were on-prem. Cloud and other things, infrastructure, and then we moved to PaaS layers and other layers. But even in PaaS, you just have to make sure that you have to select the size of the servers which you're going to use, how you're going to patch it, and all those stuff, right? And but the end of the day, serverless solves the problem, and you're focused on business logic. You're just focusing on the business logic, and you're not worried about availability, the performance, the scalability, and security and other stuff. So you're just focusing on your code, and then just sharing with the key service provider, and then everything is taken care for you from the scale, availability, and reliability, everything which will be the well architected framework uh, pillars, right? If you think from those five pillars which is there, serverless takes care of all those things, right? So that's what serverless solves for you. Yeah, that's a clear picture. Yeah.
Cool. So with that, I'd like to also talk about, like, the focus areas of what I work in, and also set some context on what we're going to learn today in this session, right? So my like you initially mentioned that I'm working as a PM with Azure Functions, and my focus areas are everything about enabling functions on Kubernetes. Also work on triggers like in the event streaming space, such as Kafka, Event Hubs, and RabbitMQ. Also work on an OSS project called Keda, which helps with scaling of pods in Kubernetes, and based on number of events to be processed. So, so we've collaborated with Drew and team here, who's here with us in the show, to launch the SQL trigger extension for Azure Functions. This is currently in public preview, and hopefully we're planning to launch it in GA soon. So yeah, I'm going to talk about what Azure Functions is about, and what is the space like, what is Functions as a service, and what are the key capabilities of Azure Functions. And then Drew will walk us through the SQL extension for Azure Functions. So the agenda, or that's what we're gonna cover today. Um, so all good.
Yep.
Okay.
Yep. Let's go
Uh,
ahead.
Cool. So also I'd like to give some perspective on, event-driven space, because we just spoke about what serverless is, and we're also seeing many modern apps, adopting this event-driven serverless architecture, because we see a lot of increase in demand for these real-time applications, integrations, and data movement, right? So these event-driven applications are also very relevant, and there are ideal scenarios, like enterprise scenarios, that need to operate at scale and in a reliable way. And this real-time communication, which is very reliable, is essential. And some of the use cases like IoT, e-commerce, financial applications often come across such requirements. And on the other hand, customers also benefit from microservices, which are built in an event driven way or in an event driven architecture, because the communications are really decoupled, right? I mean, the microservices are decoupled, but still they are talking to each other because of certain events that are happening. And these can be maintained independently, they're abstracted, and it's very flexible, where you can add in more microservices as per requirements, right? So, and event driven applications will get even better when it is deployed over a serverless approach, because serverless is most, as we spoke, it's about abstracting the entire infra layer and the management of it. It offers that agility. It also improves this resiliency and scalability, because all of that management is offloaded to the service provider or the cloud provider. And more importantly, it operates on an on-demand based, right? Like customers get to you know uh, pay as per usage. And today, if you see by a recent study, like there are by 2025, over 50% of enterprises will have their serverless applications deployed, and today it's currently at 20%. So we see a lot of adoption going up. And in this space, Microsoft offers a range of serverless environments, right? From compute services to workflow and integration services, from DevOps services. There are also database services and storage services.
Correct.
So
So Ramya, you're running through any slides there, or because I can see there is only one
yeah,
slide.
yeah, right. So I'm still on the slide because I'm talking about
Oh,
the
okay, okay.
event and the serverless part. So yeah, I think just to put in some context here. So like I mentioned, like Microsoft offers a wide range of Azure services. So like say for example, one can ingest billions of events with Azure Event Grid and use Azure Functions to process the events in real time. So with that, let me talk about what uh, functions as a services. Yeah. So FAS is nothing but functions as a service. It's actually at the center of the serverless space, right? It's actually a platform which enables users to run, manage, and scale function type of apps without having the complexity to build and manage the infra. So this platform is designed to support function apps which are event driven and with scale as the number of events to be processed increase. And this platform also helps to execute such function apps which executes for a purpose based on an event.
Ramya, we are not able to see the slide.
You're not able to see the
If you're
fast lights.
no, we just see the uh, no slide is been progressed there. We just see the first slide.
Okay, I think there's some delay in
Let
projecting the slide. Shall I stop and share once again?
Yeah, I'll just remove this from the stream, and then you can add your slides again. Yeah. Sorry, folks. I think there is some challenge in terms of sharing slides. But if you have any questions, do share those questions in the chat, and we will pick them up um, until then there are a couple of things which we have our LinkedIn group as well. So make sure that you go and join our LinkedIn group while we are waiting for the slides to come up. Cool. We have the slides. Now I can see the fast slide.
Awesome. Thanks for confirming that, Vivek.
No
So
worries.
yeah, yeah. So I was talking about the FAS, right? So the functions as a service platform which enables to run function type of apps. So this platform is actually designed to kind of support these functions which are like short-lived, which are stateless, which actually execute for a purpose. That is when an event has been uh, occurred, or and they are actually short-lived because they just process and finally they free up all the resources that they have used, so they don't stick around. Like they just complete the execution and free all the resources. So Azure Functions is based on a fast programming model, which offers this true serverless compute service.
Got it. So it's basically if somebody is coding on this, so it's basically like any function. So if you're from the programming background, what does a function do? It's basically one single task, and that's what we have used functions for. So that's the basic purpose, right? It's going to we're going to build it in a single responsibility. That's what it is mentioned there, and it's always short lived. So basically whenever somebody is invoking, that's when it is going to execute it, and it is more of an async apis which gets executed, and then after the execution, it just closes all the sessions which is just been created, and it is stateless. Obviously, there is no state, and then it is event driven. Then the main purpose is basically if there is an event happening, that's when this gets triggered. So that's how fast programming model works. So pretty much simple. From a developer perspective, it's easy to understand, right? So it's, you are a developer, you know how to build a simple task, and you just build it in your own programming language and just use it.
Right.
Perfect. Let's go ahead.
Yeah, so since I think this is a good segue to talk about like what Azure Functions is. I'm actually showcasing the Azure Functions slide. Hopefully, everybody is able to see it. So Azure Functions is a serverless solution. It's based on FAS, which offers an event-driven compute experience. So it allows developers to write less code in the language of their choice, and the infrastructure scales on demand, and users get to pay uh, as they use, or for the time that the code got executed. And using Azure Functions, you can also connect to other services without really hard coding the integrations, right? The developers are not expected to really write the connection code or a respective code that is compatible with the target service. So they can use the language of their choice and use and leverage the functions programming model and the triggers and bindings to kind of use the and talk to or integrate with various services. And Azure Functions also,
So
sorry, go ahead.
Ramya, again, you're in the fourth slide.
Yeah, I'm talking about Azure Functions and the key capabilities. Is it visible?
Again, we are no. Again, we are. Yeah, now it is going. Now it is. Now we can see.
Ramya, it's when your PowerPoint deck is what is shared and not the slideshow.
Okay.
So we're seeing
Yeah.
it. Yeah.
Okay. Okay. So I'm hoping that you're able to see the Azure Functions slide, right?
Yeah. Now we can see.
Okay, cool. Yes, so I think you essentially got like what are the key capabilities that I'm talking about, right? Write less code, scale on demand, connect to various services using the programming model, build once and deploy to multiple destinations, right? Like you could write your Azure Functions locally, deploy to Azure on the managed service called Azure Functions. Using the hosting plans that are available, you could run this code, Azure Functions code, on Azure Stack, or you could run Azure Functions on Kubernetes cluster hosted in Azure, or Kubernetes hosted on any other public cloud. Or you could run Azure Functions on an IoT device for edge computing, which is essentially you could this is powered by Docker container, where you could provision your Azure Functions on this container and run this on the IoT edge device as well. And this particular Kubernetes and the container model is based on open source functions runtime. So which is like you could have it in your registry and pull the specific functions image, write your own custom code, and deploy it to the target hosting platform of your choice or the Kubernetes cluster of your choice. So let me quickly go through the key uh, programming or the key capabilities of Azure Functions, right? In a little bit of detail. So integrated programming model is about the triggers and bindings that Azure Functions offers. So like I mentioned, one of the key components of Azure Functions are triggers and bindings. So what is a trigger? So trigger essentially causes a function to run. So it defines how a function should be invoked, and only one trigger is actually allowed that you could write in a function. Whereas on the other hand, binding to a function is a way to connect to another resource to a function, right? And bindings could be an input binding where you're essentially, this is a way for the data incoming from a source service to functions. That's when you use input bindings. And there are output bindings where you essentially channel in the data that is processed within the function to a target service. Or you could use both. So in a particular function app, you could use input binding and a trigger. You could use input binding, trigger, and output binding. So you can actually do a mix and match combinations here. But remember, trigger is something that you use only once. So like I mentioned, so the triggers and bindings will avoid you to hard code the specific connection or the target server specific code to access those services. So finally, so Azure Functions has a rich set of triggers and bindings to various Azure as well as non-Azure services. So these will help customers to define that custom logic that can be included in function apps, which will be invoked and executed based on certain events that happen in other services. So that's about the integration model. And then from an end-to-end development standpoint, Functions offers both local as well as tooling support for local as well as to quote in Azure. So it provides an end-to-end serverless development experience from building, writing code to debugging it locally and to deploying and monitoring in the cloud. So we have Azure Functions extensions on Visual Studio and Visual Studio Code for developers to quickly write function code and also like efficiently develop the code on their local machine. And this is fully integrated with the Azure platform. You can also set up CI/CD pipelines using Azure pipelines. You could actually deploy Azure Functions using Azure pipelines. You could get proactive insights about the performance of your function app using the Azure App Insights that is tightly integrated with the service as such. And finally, you could use core tools that can be used to develop and test functions locally. And the same can be deployed to Azure, or you could use your locally developed Azure functions integrated with any Azure services as well. So that's about the development experience. Now let me talk about the hosting options, right? So this is essentially about the various hosting plans, hosting types and plans that are available in Azure Functions today. So you can choose the hosting plan that fits your needs, right? Like we have several plans like consumption. So consumption is a pure serverless model where users get to pay for only what they use. And customers are charged per execution per GB second. Now we have Elastic Premium Plan, which is actually the best of serverless and dedicated hosting. So here you can actually have an auto scaling capability. There is a better performance, consistent performance that you could get because there are pre-warmed instances that are always running, which would avoid these cold start issues. And this plan also comes with certain network capabilities where you could deploy your resources in isolation, and you could also estimate and have more predictable costs. And finally, the app service is essentially a way if you have requirements to run your functions on the same resources you already have dedicated for web apps on an app service plan. So that's when users or developers choose the app service. And then, yeah, like I mentioned, functions can also be deployed on Kubernetes, and that's the area that I'm currently in. And like you could add the scaling capability using the KEDA component that is out there. And Azure Stack is also another hosting model where you could deploy functions onto Azure Stack and the IoT Edge as well. So that's a quick overview about the hosting capabilities or the plans that are available today. And finally, talking about summarizing what I just spoke, right? Azure Functions, it's a fully managed fast platform that manages and maintains the underlying infra for you. And it also offers this auto scaling serverless capabilities by provisioning all the resources that you need on demand so that you need not provision or over provision resources beforehand, like all those like you could eliminate over provisioning of resources. And it also has few plans like consumption where you could have a cost effective way of uh, provisioning your resources, and you could deploy your small spiky workloads with moderate performance requirements on these serverless plans as well. So with that, I think it's demo time. I would like to hand over to Drew to talk about the SQL extension for Azure Functions, which we have launched recently in public preview. Over to you, Drew.
Yeah, just before we go there, there is one question. I think anyone can answer this question. It's more about um, basically how complex a function should be. You want to write a few lines of code, or you want like thousands of lines of code. Like, I mean, what you have seen as part of the experience working on functions.
Yeah, that's a good question. So usually functions are short-lived, a chunk of logic that has to be processed and forwarded to the next API or another target service. So it's used for that behavior of APIs. So whether you write that code in like few lines or 1,000 lines is up to the. It's like it's not the performance is not measured by the number of lines you do, but it's usually for short-lived
Yeah,
APIs.
I mean, I would write it for a small API, basically, not really a thousand lines of code. That would be really cool, but it's kind of difficult to manage that as part of the functions, though. But what's your take, Drew? I mean,
Yeah, so if your business logic is thousands of lines of code, like that can be a function. But a lot of times when you have thousands of lines of code, it's because you're starting up the web service and you're adding the API endpoints. And like all of that is not what you have to do. You add the HTTP trigger and you've removed hundreds of lines of code. So yeah, it can be complex and thousands of lines if that's what the business logic is, but it doesn't have to be. And so a lot of times they're much shorter.
Yeah.
yeah. Th-
Also, I'd like to
So
add on that. So we have like there are limitations in the amount of time a function can run. So if and there's a certain time that the function can actually run. So if the complexity is high and then the execution time is more, then you might face issues like after a certain point.
that's the next question from the community. What's the maximum execution time for Azure function? So yeah,
Yeah, it differs for each plans. So I can drop in a link here, which essentially gives you an idea of like for what plan, what is the max time limit that is there.
For the consumption plan, Ramya, there's a lower time limit. I don't remember off the top of my head, so I'm going to say 10 minutes, and you're going to correct me if I'm wrong.
yep.
But if a developer is going to hit that time limit, there's also durable functions, which give them an opportunity to develop with a slightly different pattern, still use the Azure Functions runtime, all that powerful components, but then be able to have extended execution. So that's kind of the flexibility of Azure Functions.
Yep. And there is one more question before we deep dive. Can a function have more than one output binding?
Yes, the answer is yes.
I'm
Yes.
You
going to
could
show a
have like
sample of
one.
that. Yeah.
Yes,
I
wow.
think there is a demo, right, for this today. Yeah. So cool. And there are questions coming in. There is a question on table updates. But anyways, we're going to talk about table updates in the demo. So we'll keep that question. We can answer that question at the end of the session. Um, Obviously, there is question with respect to providers, which probably we can take it later if you want to chat about it. But anyways, let's go deep dive into your part of the session, Drew. Um, I'm going to bring in your
Cool.
guest book.
Cool. So we're looking at the screen of a sample app. It's not a super complex app because I want us to be able to see the functions really quickly and how they interact. But what the app is the guest book, which if you're too young to remember some of the golden days of the internet, you would come to a website, you would leave a note, and people could see notes that other people have entered. Now, just like this show, lots of places have code of conduct, and we might want to be able to moderate or react to the entries as they're added to ensure that no malicious content gets added. And that's what we're going to kind of see and how we built this with Azure Functions. The code itself for the sample is available for you to grab and test out and use kind of as the basis for what you're working on. But what we're going to see in these samples are input and output bindings, as well as the SQL trigger. And when we think about functions, the bindings allow us to either pass something in. So if we want to pass in data from a SQL database, we can do that with an input binding. If we want to write out to tables, that's what an output binding would be. So when we were talking about like, can you have more than one output binding? We're going to write to two tables at the same time with putting two output bindings on a function. And then the SQL trigger is when, if there's any kind of data change, data inserted, data updated, data removed, that's going to start the function running. So there's that way to be responsive or event driven based on the database. But that is enough talking. Let's look at code. I'm over in VS Code, and I've got APIs, a couple different folders of those. I've got a guest book folder, and this is an Azure Static Web App. You could use just plain HTML. You could use a different framework. I've used React here because I'm a little bit more comfortable with it, but that's kind of, Functions doesn't care, technically speaking. If we anthropomorphize it, you can be calling to functions from any interface you want to. The reason why I like Azure Static Web Apps is that you can proxy to Azure Functions quite a bit easier. So we'll be able to tie an Azure Functions instance right to Azure Static Web Apps and not have to worry about cores. And then the last thing we have is a SQL project. And this gives us the core of our sample where we have a database that we're going to be writing all this stuff to. The first set of Azure functions that I want to look at real quick are going to be pretty simple. We're writing to the database and we're reading from the database. This is kind of the crux of this interface here. How do I get this list of entries and how do I write a new one? And so we're going to have an output binding to write out to the database, and we'll have to have an input binding to query that existing database. The thing about functions and why they become fantastic for development is you have different languages to choose from. So I've got JavaScript APIs, I've got .NET APIs, I've got a PowerShell API. I'm able to break out which languages I'm most comfortable with. And in this case, we have an API for add entry and get entries. So the question around like how complex or how simple does an Azure function need to be? If I'm getting a list or a set of rows from a database, this is what my function could look like. This recent entries parameter is coming from my function.json, where I've defined that SQL input binding as a query on the database. So that was what it took to get that connected and say, hey, when I run this query, we're going to pass this into the function, and that's just going to return it back to our front end. It's quick. I'm not going to belabor the point on these JavaScript functions. They're pretty similar. We've got a new entry where we're writing out to a table. But I'm just going to show you how straightforward it is to start these functions locally. So if I go to my APIs folder and say func start, I'm now using those Azure Core tools locally to run these functions. So now I can test and use them. The same thing applies for my Azure Static Web Apps. If I go to my guestbook folder, then I would be able to use my guestbook. I've already run npm build, but let's do that just for good measure. The right command. And that's going to make sure that my statically rendered website is up to date in my build folder. Awesome. Let's start the static web apps runtime locally. I'm going to point it at that build folder But the other thing that I'm going to do, like I mentioned about how we're proxying from the front end static web app back to the Azure Functions, is I'm going to point at the API location here on my local machine, 127.0.0.1, and the port we saw is set to port 7071. And that's for these two real simple functions, writes to the database, reads to the database. That's pretty cool. And so now our website is live. If I refresh the page, it's there, it's responding. That's great. We can see those calls happen in the background, and we can see their logs in the Azure Functions.
So very interesting for community if you're observing this, right? This has been built on Azure Static Web App, and it is also running locally for you, and you're also running the functions locally, and and you're testing it out, and it's all, if you see the interface, it's all local. So that's the flexibility of Azure Functions, giving you that flexibility of building it locally, testing it locally, and also you can deploy directly from here to the cloud. That's the programming model. Important thing to note. This is the programming model, the programming structure for building a functions. So go ahead, Drew. This is interesting.
Yeah, that's a really good thing to call out, because I want to be developing locally where I can make changes and not be waiting for something to deploy or concerned about breaking something. I mean, the database itself is running locally in a container on my machine. So I have this whole development layer to work with. Now, the real exciting thing is looking at, after we've written data and read data from the database, which we'll do and test here in just a second, but we do want content moderation to happen. And while you could, when you're writing to the database, run the content moderation at that time, a lot of times you get event-driven architectures coming from, I have multiple things writing to the database and I want to be able to respond to all of them. I'm not able to change this code or that code. So we want to respond to changes to a specific table. That's where the SQL trigger comes in. And so that is what I've got my .NET functions for. The SQL triggers available in public preview for C# functions. And get the terminal out of the way. When you write a C# function, you get these function decorators that tie it into the functions runtime. And the one for SQL trigger here points it at the app.entry table and reads changes from that. Let me get that out. So we're able to get a function run every time there's a change to that table. So if I write to the table, insert a new row, this function is going to run.
So how do I get started with this extension, the SQL extension? Like if I want to, I'm writing .NET code, and is it a NuGet packet where I can just install and use it, or
It
is it
is.
something I need to draw? Okay, it's a NuGet packet. Okay.
Yep, it's
That's
a
the
NuGet
extension.
package. There's an aka.ms/SQL trigger. That link will take you to the docs that'll give you the .NET add package link, and then kind of give you the syntax around this is how you would define the trigger. So you can certainly get started from the docs. There's also a link to the repository for the SQL extension itself. So this package, it's open source. There's a repository. There's a ton of samples in there. So you can kind of get started however you learn best, whether it's from documentation or samples. But yeah, absolutely.
Got it.
The question earlier about writing to multiple tables, we're writing to 2 SQL tables here. And we've been seeing this entry table a lot. The entry table gives us just the text entry that's been added, the date it was created, and then there's a bit column, a true false, for whether or not it should be disabled, whether or not it should be removed. And we populate that along with some moderation information. Did we find any profane terms in this entry that was added? And so both of those tables are written to by this function. Now, we were talking earlier kind of about function complexity and how would you end up with thousands of lines of code. This function's not super complex by any standard, but it's a little bit longer than the ones we saw before. We're doing things like getting environment variables, getting app settings. We're going to connect to Azure Content Moderation Services. You can be calling out to any kind of service that you need to serve your business. But in this case, we're going to call out to Azure Content Moderation Services. So we're setting that up. And then you get the set of changes in a batch that you set the size of in your app settings. There are defaults that give pretty good performance, but you might end up needing to fine tune that. But we get a batch of changes. And so for each one of them, we're going to take care of our logic here. And that logic is, if we've added a new row, this is what we want to do. We're not going to do anything if we're updating something that's already in the entries table, but we want to, if we've added a new row, send it for text moderation. And then if we got profane terms found in our entry, we're going to remove it. Like we don't want that to show up. The way that we're removing it, and the thing that's great about bindings that I really want to call out to, is these objects, entry updates. That's part of our output binding to app.entry. And so that object gets transformed into what gets written to the SQL database. So if I follow entry updates through this function, it gets populated from updates. And every time we have an entry that needs to be disabled, we've added it to this updates array. And so when we make something that's to disable, where we set disable view to true, that gets added to that object. So we're transforming this C# object into what gets written to the database without having to think about, like, how do I write update in T-SQL? Like, if that's not your jam, well, you don't want to worry about it. Use SQL bindings. All right. So that's cool. But I've been talking about code and not running it, so let's run this. With the functions local runtime, I've got one instance running here for those JavaScript functions, but I can run it again for these .NET functions. The only thing I'm going to do is it's going to look for a default port to associate itself with, so I'm just going to point it at 7072 instead of 7071. And that's going to start this up. There aren't any HTTP endpoints in this functions instance. The only function that we have is this moderator function that uses the SQL trigger. That's it. When we see the SQL trigger run, in the logging, I've added a few log entries that we'll be able to see. We'll be able to see the log for the change operation. We're going to see what it's moderating. And then if it found profanity, we're going to get a warning message in our log. So we'll come back here, check our log, make sure it did what it said it did. All right, so hello. We'll start by just like leaving a nice message. I add that, it gets added here. If I refresh the table, like it's still there. Cool. If I expand my terminal, we can see that the hello from Microsoft Reactor insert operation happened, the function ran, and then it wrote one update operation, and that was to confirm that it should stay in the view. All right, that was not super exciting, but pretty cool. I mean, the function ran because I wrote to the table. Like, we can see the entries now in the table. That's great. If I check my moderation table, there's nothing. It's empty. Okay, let's get spicy. So the cool thing about Azure Content Moderation is that you can define custom lists. So you can say, these are specific terms that I don't want to see, that I want to have moderated. So I don't actually have to curse to make this happen. I added a few extra fun terms that I made up that don't actually mean anything, to be able to pull those out from content moderation without having to actually curse in this. So I'm just going to say this content should be removed because it contains the word snarf. So this word has been added to my instance of Azure Content Moderation, and that'll pull this content out. So I wrote that entry, and it went away. Like, if you caught that, it was there for a second, and then it's gone. So the JavaScript Azure function wrote it to the database, and then immediately the SQL trigger took off based on that update to the table. Change operation insert. There's our comment. And then there's our warning message, profanity detected, disabling view. And this took about 700 milliseconds, so a little bit under a second. I'm running everything locally except for Azure Content Moderation. So I had to call all the way out to the Azure data center on the eastern side of the US and back. Overall, it's pretty quick once you put everything in Azure together, but even less than a second is pretty darn good. And then we did the update operation, that output binding that we saw that writes to the entry table. If we go back to the entry table, we see the disable view got set to 1. So now it's not on the list. And we've got some profane terms that were found that were written to our database too. So we were able to write to both tables in that function. So that kind of encapsulates when you see all of the different operations that SQL bindings and then the SQL trigger are capable of right on one very small little app, and how that kind of can quickly come together.
True. Do you want to call out the magic sauce behind, whenever these changes are happening?
Yeah,
execute it. So
absolutely. So that's a great call out. The Azure Functions SQL trigger is based on change tracking. And if you're an expert in all things SQL, you might think like, oh, there's all these different options for watching for changes in SQL. Why would you use change tracking? The number one reason that I always give is that I haven't said like which SQL you have to use yet, because we use change tracking is compatible with a ton of different versions of SQL Server, Azure SQL Database, Azure SQL Managed Instance. Kind of, you don't have to find a whole new database to use this. Whatever one you have now, it will use. The SQL trigger itself will add a few tables and then this Azure Function schema just to kind of manage its state and watch the rows that it's processed. But change tracking itself is a really quick thing to enable, and it's very lightweight as far as how it functions. So it's a really nice thing to have for SQL trigger. If if you're like I mentioned, kind of if you're an expert and you're up at a new level, you're going to know there are tons of different options for change processing on SQL. The SQL trigger is going to be the fastest one for you to get started on, because it combines kind of the great development environment of Azure Functions with a really easy setup on SQL. Great question.
So
The
So
other
the users can essentially alter the table and turn on the change tracking, and then
Mhm.
yeah, that's
Yep,
yeah. There you go.
that's it.
Yeah.
um, the other question I had was like, where do you provide which SQL to use? Like,
Yeah. So the 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 definition for, we'll focus on the SQL trigger for a second, has a few parameters. The first one was the table name, and then the second one was the connection string setting, and it's an app setting name. So if I go in my
okay,
app settings, yeah, I've got a number of things, including my local connection string. This is the local development file. You're not going to have your file sitting in plain text in Azure. It's going to be in the secure app settings. And then it can be managed by things like Terraform, Bicep, Azure CLI. All of those things can come into play. But yeah,
got it.
absolutely, it's an app setting.
Yeah, there was a
Oh,
question about, hey, what is the max execution time? So that there's an app setting for that, max connection timeout, that can be set in local settings.json as well, or functions.json.
I see a good question around like how near time or how quick is the performance impact of change tracking. The one we saw today was in that sub 1 second range, because we've got we're calling out to Azure content moderation and then back to my machine. When everything's in the same area, you're going to be even lower than that. But overall, the latency is very, very short with change tracking because it is so lightweight. The follow-up question to that is, what is the performance impact of change tracking? The bigger question a lot of times around change tracking is like, what's the storage cost of that? Because in the background for change tracking, you've got the tracking history that goes along with that. And so I've got a stored procedure that checks these internal tables as to whether or not it has been able to process through all of the changes, and is that table healthy. And so you can kind of see and manage those things. There's an automatic cleanup function within SQL that removes rows that have been processed after a certain time period. And so there is a performance cost to that, but it is minor. And so it's able to be A, auto-managed by the engine, but B, also something that you can see based on that. But change tracking itself is a very lightweight option within SQL for tracking changes. Not to use the word in its definition, but yeah.
so I have a question actually. So, which all programming languages are supported uh, for for this extension? I know that it's supported for .NET, but
Mhm.
what other programming languages are supported as of today?
So as of this very moment, the SQL trigger is available in preview for the C#.NET Azure Functions. And then the SQL bindings are now available for all of the languages that are offered by Azure Functions. So that'll be your JavaScript, Python, C#, Java, PowerShell, the whole gamut. The both bindings and trigger are in preview, and so the trigger is going to be getting the rest of those languages here soon.
Got it. Got it. So it's basically It basically monitors everything from a table change perspective. Like you can build it with inserts and updates and deletes. You can do triggers on any of these operations, right?
Yes. Yes. So when you get that change from the trigger, there is an attribute to it where you can see, is it an insert, update, or delete even while you're running.
Got it. There is a question actually.
Mhm.
So the question is, do one need to still write a stored procedure for every SQL trigger binding?
You do not need to write a stored procedure for the SQL trigger. It is going to be on a table. So you would have a function for every trigger. So you can only have an one trigger on an Azure function. So if I want to track more than one table, I would need another Azure function to track that other table. But you don't need to use SQL stored procedures to use the SQL trigger at all.
There are some questions coming in.
Mhm.
Uh, that's a big question. So it's like working in a bank and having CDC on mainframe, moving data to SQL, and then integrate with change tracking, implements event-driven architecture to mainframe. Oh wow, nice.
Yeah, that's
Oh,
cool.
this is a comment. I thought this is a question. So this is a comment. Yeah,
Yeah,
yeah, true.
it's awesome.
That's an
It's working out
interesting.
for you.
Yeah, there are some other questions coming in. Okay,
Cool. Yeah,
perfect.
let's
So
see.
is there any possibility that change does not reach to Azure function? If yes, then how can it be retried?
Mhm.
So basically, there's a retry policies. Does that work here?
So there's a number of different layers of retry policies within Azure Functions, and Ramya may want to add something to kind of that comment. But within the SQL trigger itself, it tracks which rows it has processed. So let's say I turn off all of my functions and I make a change to the table. It's not going to get processed until the function runs. Or let's say there is a network break between my database and my functions. The changes that happen to the database aren't going to get processed. And until the trigger runs and marks them as processed, they will get to be retried once the function is available to the database and it runs it. So in the event that the change does not reach the Azure function, it will retry it until it is marked as processed. That's what these additional tables are handling from the trigger. Ramya, was there anything about functions retry that you wanted to add?
Yeah, sure, Drew. And before I talk about Azure Functions, recently there has been a change that has been added, right? Like where users can, like, if there is a connection breakout that has happened, the connection is like tried for a certain amount of time, and that's now supported with the SQL Trigger extension. So from a
Yep.
connection standpoint, the retry has been handled. Um, but yeah, in Azure Functions, generally, we are actually moving away from having a dependency for Azure Functions having a retry policy, because like individual target or individual services have their own way of retrying mechanisms. So we would really like to like depend on, like, have that included in your logic, so that service specific retry is being implemented. But having said that, like for Event Hub, Kafka, we have inbuilt retry policy that has been created, where if there are any exceptions, that where you can actually have a way to kind of implement the retry logic for those
Mhm.
uncaught exceptions. Yeah, for some triggers.
Is it configurable? Like the retry policy, say for example, I want to retry until these number of times until the function is available, and probably if it is not available, give a proper message to the to the user that saying something is down and probably you should try later or something, a useful message for the customer. So basically a customer, I mean, my scenario is basically a customer is trying to do something, and it is trying to insert some information in the table, and the function is not available out there, and you are trying for some time, and then you have to provide a proper message back to the customer, right? So is there in a minimum, or whether I can do 20 retries and come back and say, hey, this is pretty much the service is not available for longer time, so I just have to inform the customer, right, for the usability and experience perspective. So how do I build that out?
Drew, you want to talk about the SQL part, but for the supported triggers, right? The retry policy that Azure Functions supported for triggers like Kafka and Event Hubs. So we have a parameter called fixed delay or exponential backoff that can be configurable with the number of seconds that this has to be retried. So a fixed delay is like you define a specific number of seconds and it tries every fixed amount of time. Exponential is like it keeps, uh,
Yeah.
like the time keeps increasing as per the thing. So that's a configurable thing. But coming to the message, I think we really don't have like a default out of the box message that is coming out from a library or anything. It's up to the user to kind of handle that, the custom message.
For me, my response would have kind of two parts. The first one is for SQL trigger and input output bindings. The connectivity to the database, there are retry parameters within the connection string. So as you define your connection string, you can add connection timeout and that retry policy in that connection string itself. However, like if we think about SQL trigger, that function is running because a change has already been made to the database. If I'm stepping all the way back to like my user is interacting with my app, how do I make sure that if the function doesn't respond, I'm able to let them know something's wrong? I would be all the way back out at my front end. In this case, because it's a React app, I've got services defined. So this is part of what would be the static web app, and the function that the code function that calls to Azure Functions. I don't have a try or catch here. Like this would be terrible user experience. If it failed, doesn't do anything for that. Or for when it tries to get the list, there's a try and a catch with an error that gets logged to the console. So that's a little bit better. But I could, sorry, the entries could not be loaded. Like I could try and catch the error here on the front if I want to get that to my users. Is where I would end up with that. So.
Got it. I think that will be a way to design that architecture if we have to make sure that the customer experience is met. Oh, that's a good one. We don't have any more questions in the chat. Um, yeah, so we can continue, or we can wait for some questions to come in as well.
For the most part, that's the bulk of the demo. Oh, that's my favorite question just came in. Oh, yes. Okay. Yes. Can we use managed identity? Yes. 100% yes. I've given this demo in the middle of a expo hall where everything was deployed to Azure, and like I could pull up my connection string in the app settings and everything because there were no credentials in there. So you can absolutely use managed identity with this. There is even a walkthrough article. There's even a walkthrough tutorial article on connecting your function with managed identity. This will apply to both the SQL trigger as well as the SQL input output bindings. And the crux of using managed identity, why I get so excited, is that Instead of having username, password in your connection string or anything like that, you assign an identity to the functions themselves and then add those users to your database. So that would look something like this. Like, I'm going to create a user from external provider that represents my Azure function, and then I give them some access rights specifically, probably with finer granularity than that, but that's just the example.
Got it. Uh, so basically, I could go back and use this managed identity in this format as well. So that's good. Um, let's wait for 2 more minutes if there are any questions. And so Parth, can you share the link as well for the people if they want to go back and learn this out? Can you share it in the chat so that I can share it to the community as well? Yep. Nope. That's not the link. I think you published the wrong link. Cool. This
There
is
we
the
go.
link. So
That's it.
so we have this link. So you can go ahead and try this out as well, and make sure that you play around with this. And I have shared the GitHub uh, repo link as well in the chat. This is the GitHub repo. This is the code which Drew is using, and it has details how to get started, and you can see the different tools he's been using, and you can try and deploy this on Azure, the complete function on Azure, and play around with this new extension as well, so that you can understand how to build this out for your projects, right? So this is interesting. So just try this GitHub repo, and just go there and play around with it. And yeah, you can, for further readings, I'm just going to paste this link in the chat as well, and also show it here. This is the link, and you can take this link further. Cool. And I'm not seeing any more questions coming in, and uh we're just over time as well, 1 hour 8 minutes now. So we could, you know close this session.
Yeah.
And for people who have joined, you can definitely reach out to us if you have any questions when you're playing around with this. And if you have any questions, do reach out to me, do reach out to Drew, do reach out to Ramya, and we are very happy to answer these questions as well offline as well. And I just want to say thank you to Drew and Ramya to be on the show and share your insights on different things. We had an amazing discussion on various things, from building how to starting with what is serverless, and what are the things which is available as part of the functions, and how to do the local development as well. And then obviously talking about the extension which is there, right, which is Azure SQL extension trigger for functions, right? So please go ahead and try it as well. If you have any questions, do reach out to us. Thank you, Ramya. Thank you, Drew. Thank you, Pat, for hosting us. And it was really fun to see this demo. It's interesting. Thank you for being on the show.
Thanks so much for having me. This was great. Thanks, folks, for joining.
Thanks, Vivek. Thanks for the show. We had good time. Nice Friday evening and a happy weekend. Bye.
Thanks, all. Have fun. Do join us for the next set of shows. It's going to be amazing as well. Bye bye. Take care, everyone.
Bye.